Welcome, geometry students, to the homework help video, page 239. Let's go ahead and get started. My voice is pretty bad today, so hopefully you guys will be able to hear me. It's locking up a lot today, so we will see what we can do here and hopefully get through this video. Okay, here we go. Numbers 1 through 5. Given, okay, I just did something I didn't want to do. I have no idea what it was. So, okay, moving on. I don't know what happened. Sound like we took a picture. Okay, probably did. Okay, here we go. They want to know where the mid-segment is over here. Now remember, a mid-segment always connects the midpoints of two sides of a triangle. Like here's a midpoint, here's a midpoint, okay? It does not come from a vertex. It does not, okay? So let's look for a segment up here that cuts, that is at the midpoints of two sides. So here we go. Now notice here, guys, that WC is congruent to CX. So here's WC, and here's CX. So C is a midpoint. C is a midpoint, okay? Now notice here that YE is congruent to EX. So YEEX, so E is a midpoint. So if C is a midpoint, which it is, and E is a midpoint, which it is, then CE is a segment connecting two midpoints. So a mid-segment in this diagram here would be CE or EC. Okay, number 2, a perpendicular bisector. Now remember, students, a perpendicular bisector, that was not good, was it? A perpendicular bisector is a segment that is perpendicular to a side, and it's in the middle of the side. So it would probably run from, let's say here's a midpoint, and then perpendicular, it would go like this. Now it doesn't have to hit the midpoint over here. It's not important. But here is the midpoint, and we have a right angle. So we're trying to find a segment that comes off of the midpoint and has a right angle. Well, we already said, guys, this is a midpoint here, and this is a midpoint here. So do you see any right angles at those points? Well, yeah, booyah, right here, look. This is a right angle, right there. So this segment right here, CD, forms a right angle, so it's perpendicular, and CD hits a midpoint right here. I know that this segment here, WC, is congruent to CX. I learned that right here. So CD is a perpendicular bisector. Okay, very cool. Or as my wife says, cool beans. All right, let's move on. Number 3, angle bisector. We're looking for a line that comes off of a vertex and totally cuts the angle in half, like this down here. A line coming off this vertex in such a way that this angle here is congruent to this angle here. So we don't see any marks here for angles. We don't see any marks over here, but we do see some here. Now follow the red lines carefully. It goes from here to here, and from here to here. So this line right here, BY, is cutting angle Y in half. There it is. Angle of BY is cutting angle Y in half. Okay, so BY or YB is your angle bisector. Okay, very cool. Moving on, number 4, an altitude. Now, an altitude is a line that comes from a vertex and forms a right angle with the opposite side. Okay, so it would look like this. Let's see here. Let's draw a different triangle. Let's draw one like this. Okay, the altitude of this triangle here would come from this vertex and would come down and would hit here and form a right angle. So we're looking for a line that comes from a vertex and hits the other side in such a way that it forms a right angle. Well, I think I found it. Look at YA. YA or AY comes off of vertex Y, and it forms a right angle. So there it is. AY is an altitude. Okay? All right, moving on to number 5, a median. Now remember, a median, students, I'll do it in green here for you. It comes from the vertex and it hits the other side at the midpoint. It's not necessarily perpendicular. It can be, but it doesn't have to be. Okay, so here's the median right here. It comes from the vertex and it hits the midpoint. So remember, here's my midpoints. Here's my midpoint. And here's my midpoints. There's my 2. Now I'm looking for a side that comes off of those midpoints and goes to a vertex. Well, this line here coming off of E, it doesn't go to a vertex. It goes over here. So look at C. This line right here, this is it. Look at this. This line here comes from a vertex right here and hits the midpoint. So CY. CY is a median. There we go. Moving on to number 6. Okay, construct the incenter of an acute triangle. Okay, here we go. Acute triangle. Okay, let's see what we got here. Here's an acute triangle. Just draw a little triangle like this. There we go. I better not do this small. Make it a little smaller. Here we go. Acute triangle. And we're going to draw the incenter, which is where the angle bisectors intersect. So here's an angle bisector, cutting this angle in half. But you did not have to do this with your compass and protractor, okay? Straight edges are good enough. And then all they wanted you to do here was review what an incenter was, students, okay? That's it. Nothing else. Okay, there we go. And then we're going to cut this angle in half right over here. And there we go. We constructed the incenter right here. Okay, moving on to number 7. Construct the centroid of a scalene triangle. So here we go. Scalene means no sides are congruent. There we go. That should work pretty good. Now centroid is where the medians intersect. The medians. So the median runs from here to the midpoint. From here to the midpoint over here. And from here to the midpoint over here. So students, there we did it. We constructed the centroid right here. There's the centroid, okay? All right, moving on to number 8. Construct the circumcised circle, circumscribed circle of an obtuse triangle. Now, let's see here. Guys, I want to point something out to you. We learned that the incenter, let's go back a page. Listen to me carefully. We learned that the incenter is always equidistant from the sides. So an incenter, if an incenter is equal distance from the sides, that means this here would be the center of a oh, you know what? Hold on one second, guys. I'm confused. I was thinking it said inscribed. It says circumscribed. That means they want us to draw a triangle and then draw the circle around it. Okay, so, okay, hold on one second. Let me look this over. Okay, guys, I'm back. Sorry about that. Okay, guys, think about it for a second. If I want to draw a circumscribed triangle, okay, just don't take notes. Just watch for a second. Now, that means the circle has to hit all of these vertices. Okay? Like that. That's a beautiful picture, isn't it? Well done, Mr. Earhart. Great job. But you get the point. So think about it, guys. I need a point that is equidistant from all the vertices. Because guys, listen, if this point, listen to me, if this point is equidistant from the vertices, then this point is also equidistant from the point on the circle. Thus, this point here would be the center of the circle. Now, we learned something called a circumcenter. Okay, you learned this, guys. You might not remember it, but you did. It is where the perpendicular bisectors intersect. Well, we also learned something else about the circumcenter. Okay? It's equidistant from the vertices. So if I can find the circumcenter, then I'll have the center of my circle. So watch how I do this. Okay, here's my obtuse triangle. There it is, okay? Beautiful drawing. Now, let's go ahead and draw some perpendicular bisectors, okay? So here's my midpoint and perpendicular. There we go. Now I'm going to draw a perpendicular bisector over here. Here's my midpoint approximately. And perpendicular looks like it would be about, well, let's see here. Hold on one second. Probably about right here. Okay. There we go. Now, here's my midpoint here. So my perpendicular bisector would be about this here. Okay. Now I know my drawing's not going to be perfect. Surprise, surprise. But if we extend these like this, they're going to intersect in one place. Or at least I'm going to make them. Okay. So there's the center of my circle. I did it. Okay. See, listen, guys. Listen to me, guys. Whenever you find the intersection point of your angle of your segment bisectors, that point is equidistant from the vertices. So this point, this distance here to the vertex, this distance here to the vertex, and this distance here to the vertex is theoretically the same. So I can draw my circle. Now this is the center of my circle. So this is my center. Okay. I really can do this pretty cool. I can do it like this, guys. I can go draw a line here. And this is not going to work. Okay, draw a line from here to here. Draw a line from here to here. These are all radii of my circle. Okay? Now, let's do some more of these, okay? Just for the fun of it. Okay, so there's one. Let's pick this up and we'll put it right here. Oh, not both of them. Come on now. Okay. Let me turn off the video so I can yell. All right, let's try this again. Put that right up here. Okay. I'm going to guess on the next one. About right here, same length. So guys, I'm so ready to draw my circle now. Okay. And it's a thing of beauty. I have never seen a better circle in my life, ever. There it is. So you drew a triangle, okay? That is circumscribed. Here it is. Your triangle's right here. And you say, Mr. Earhart, what do you mean by circumscribed? Well, the vertex of each triangle lies on the circle. The vertex of each vertex of the triangle. Each vertex of the triangle lies in the circle. There it is. We did it. That's it. That's exactly what they wanted. Okay? All right, number 9. P is the centroid. I guess I'll read the directions first. Directions say to use triangle ABC. Okay, so we have to draw triangle ABC. You can draw it however you want to. So here we go. I'm just going to draw it like this very quickly. Not going to try to be that picky about it. Okay, there's triangle ABC. And why did I draw triangle ABC? The directions say, use the given information about triangle ABC. So here we go. P is the centroid. Okay, what is centroid, guys? A centroid is the intersection point of the medians. Let's draw some medians. Okay, here's a midpoint. This is such a great mid-chapter review, guys. It really covers a lot of stuff. And there's a median. There's the median. Okay, now CP, P is the centroid. So here's P right here. CP is 6. Okay, find PD. No, it says D is the midpoint of AB. So here's AB right here. So D is the midpoint. Find PD, find this length. Well, guys, we learned that whenever you find the centroid of your medians, each length is divided up into 2/3 and a third. In other words, this segment here is twice as big as this segment here. Okay, so if this segment here is 6, then this segment here is 3. So the answer is 3. And by the way, if I would have told you the whole segment, DC was 9, by the way, this whole thing, then how do you find each piece? You take 9, always divided by 3, and then you get 3 here, 3 here, and 3 here. So this segment here is 6, and this segment here is 3. Okay, but either way, the main thing you want to learn is this. Whenever you draw the centroid, this segment here will be twice as big as this segment here. Or you could say this segment here is twice as big as this segment here. Or you could say this segment here is twice as big as this segment here. Okay? Moving on to number. So the answer is 3. Okay, hopefully I didn't confuse you. The answer is 3. Okay, number 10. AE is the perpendicular bisector. Okay, so that means from here to this side here, so that's perpendicular. No, my bad, sorry. AE is a perpendicular bisector, so we find the midpoint and then draw a perpendicular line. There we go. But you know what? That's not going to work, my bad, because it says AE is a perpendicular bisector. So A has to be on this line. So I see now what they want us to do. Okay. All right, so really good. This is a really good question. I love this. Okay, here's what they want you to do. They want you to draw a right triangle. Okay. And then, let's see here. Nope. Wrong again, guys. Sorry. I love it. Draw an isosceles triangle. There we go. And put A up here, and B here, and C here. Now watch this. This is so cool. Draw your perpendicular bisector like this. There we go. Much better, okay? BE is 4. So what would BC, the whole length, be all the way across? Well, from here to here is 4, and here to here is 4, then the whole length has to be 8. Okay? Number 11. B's the incenter. So here we go. Here's our triangle. We'll call this A, B, C. P's the incenter, and of course we know that an incenter is where the angle bisectors intersect. So here's an angle bisector. Hopefully. Here's an angle bisector. And here's one. Okay. Now the incenter is P. Angle CAP is 30, so CAP is 30. Find angle PAB, this angle here. Well, guys, it has to be 30. Remember, in order to draw an incenter, you have to draw angle bisectors. So this angle here is congruent to this angle here. This angle here is congruent to this angle here. And this angle here is congruent to this angle over here. So if this is 30, then this angle here also has to be 30. Okay, so PAB would be 30. Okay? All right, moving on to number 12. All right, let's draw our triangle ABC. DF is a mid-segment parallel to BC, so it has to run parallel to BC. So DF must go from here to here. So there's DF, okay? So DF is a mid-segment parallel to BC. DF is 4. What is the length of BC? Well, guys, if you took good notes and you listen in class, you should know that a mid-segment is always half the side of the mid-segment is always half the length of the third side, or you can say that the third side here is twice as big as the parallel mid-segment. So if this is 4, then BC would have to be 8. Okay, so there we go. All right, moving on to number 14. This will be a good one. This will be good, okay? Here we go. Okay, students, want to give me a coordinate plane there real quick. All right, let's go ahead and plot these points. -2, 0, and 0, 2, and -4, -1. 1, 2, 3, 4, -1. All right, so here we go. Now, students, think about it. These are the midpoints of the sides of a triangle. So if I connect this right here, that means this here has to be parallel to the side over here. This side of the triangle here, okay? So what I'm going to do is I'm going to find the slope of this line here, which is over 2 and up 1. So from this point here, I'm going to go over 2, up 1, over 2, up 1, then go down 1 over 2, down 1 over 2, down 1 over 2. I think I messed up there on that one, didn't I? Down 1 over 2. Okay, so there we go. I'm going to draw a really long possible third side of this triangle. Okay? I'm going to go ahead and put a different color on my midpoints. Here's a midpoint. Here's a midpoint. And here's a midpoint. Okay? And by the way, students, if I know this is the midpoint right here, which it is, then I can go ahead and just do this. Well, I better hold on 1 second before I do that. Okay. Now, if I draw this mid-segment right here, this one right here, I'm going to go ahead and make our mid-segments black here. Okay, if I draw this mid-segment here, like this, then my other side I'm going to draw has to be parallel to that side. It has to look something like this. Go through the third point and be parallel to that mid-segment. So here's what I'm going to do. I'm going to find the slope of this mid-segment right here. So I went over 3, 4, and up 3. 1, 2, 3. So from this point here, I'll go over 4 and up 3. And look at that, it hits right here. Okay, so now I know the third side of my triangle. We'll go from here to this point and continue on this way also. So let's see, I went down 3 over 4, so down 3 over 4 right here. Okay. Now my last mid segment I'm going to draw is this one here. Okay. And so the side that goes through this point right here has to run parallel to this side here. Well, the slope of this mid segment here is over 2 and up 2. So from this point here, I'm going to go over 2, up 2, to right here. Right here. So there it is, guys. There it is. There's the other side of my triangle right here. From here to here. I've never seen a worse drawing, but your triangle is from, I'm going to change colors to green. I don't know how this is going to show up, but anyways, there to there to there. So there's your vertices right there in green. Okay, well, it's really tough, but there it is. So 1, 2, 3, 4, down 1. So -4, -1. Okay, and over 2 up 1. So -2, 1, and then here over 2 up 3. Okay. All right, continuing on. Number 15. Now this will be a proof. Okay, this is tough. So let's go ahead and get started. This will be a really good long proof. So here we go. Okay, first of all, we have triangle ABC. Okay. And we're told this segment here is congruent to segment here. And CM is a median. So draw a median here. Okay, so when I draw the median, I know this is congruent to this. And BN is a median. Let's go and put M here. CM and BN is a median. So B to the midpoint over here. So we're going to say that this segment here is congruent to this segment here. Okay? So we're going to prove that CM is congruent to BN. Okay, that's our goal. Well, this is going to be really hard and challenging, which is good. Okay, so we are given all of this here. Okay, AB congruent to AC, CM, and BN are medians. So CM, BN, medians. And we're going to prove that CM is congruent to BN. Okay, so there we go. Now here's my plan of attack. Watch this carefully, students, okay? This is going to be a really tough proof. I'll probably lose a lot of you, but that's okay. Here we go. Okay, students, here's our plan of attack. Okay, watch this carefully. I would just take notes on this if I were you guys. Okay, now watch this carefully. Here's my plan of attack, students. If we're going to prove, now take some notes on this and listen. Okay, we're going to prove that this segment here is congruent to the segment here. And here's my thoughts, okay? Put it in here. Here's my thoughts. I think we're going to have to prove this triangle here is is congruent to this triangle here. And then once we prove that, then their parts are congruent, so we can state that BN is congruent to CM. Okay? So here's how I'm going to do this. Watch carefully. I'm going to copy this triangle real quick. I'm going to pull it off to the side here so we can work with it, okay? And it's not what I wanted to do, but that'll work. Now, I want to copy this triangle here. We'll try to pull it over here. There it is, okay? So this triangle here would be ABN. Okay? And this triangle here would be it's incorrect, sorry guys. BAN like this. And then AMC. Now, look students, first of all, these two triangles already share this side here, or this angle here, okay? And then look at your given back here. We're given that AB is congruent to AC right here. Okay, so we know that this side here is congruent to this side over here. Okay, now it makes sense, guys. Look, we know that this segment here is congruent to this segment here, and this segment here is congruent to this segment here. But how can we prove that this segment here, AN, is congruent to this segment here, AM? Well, guys, segment addition. Here's my brainstorming. See this whole segment right here? I'm going to put this, I'm going to say AM plus MB equals AB. Okay? And then I'm going to say AN plus NC equals AC. And now look at, I'm going to circle each step so we don't lose sight of it here, okay? Put this up here, put a little circle around, okay? Then look what I can state next, guys. Look, these here, this segment here, AB, I know is congruent to AC. Okay, we already know that. And look what else I can put. Now watch this. Students, right here I can put, look, I want to keep AN and AM, because if I can somehow prove that AN is congruent to AM, then I've got side angle side. Okay, so watch. Leave your AN here. Now what is AN congruent to? NC. So see this NC right here? I can put AN for that. So I can have AN plus AN equals AC, which is the same thing as 2AN equals AC. Now look right here. I want to keep my AM. What can I put for MB? Well, MB equals AN. So for MB, I can put AM. So I can put AM plus, and then for MB, put AM equals AB, which would give me 2AM equals AB. Now, students, look at this. What do we know in our given? AB is congruent to AC. We know that. So, in my next step here, I could get rid of either I could put AB for AC, or I could put AC for AB. Either way is fine. I'm going to do this. I'm going to put 2AN equals AC, and then I'm going to put 2AM equals, and what can I put for AB? AC. Definitely. And now I can look at 2AN equals AC and 2AM equals AC. I can state that 2AN equals 2AM. I told you it's a really tough proof. And then divide both sides by 2. AN is congruent to AM. There we go. So that's my plan of attack. Love it or hate it, okay? So here we go. Statements, reasons. Woo, here we go. All right. I have my given, okay? All right, next, I know I'm going to have to state somewhere that AM is congruent to MB and AN is congruent to NC. Now, how can I do that? Definition of a median. Definition of a median, okay? We're told this is a median and this is a median in our given. So, definition of median, okay? Now next, I can state that angle A is congruent to angle A. Okay? Reflexive. Next, I can do segment addition, okay? Segment addition. So AM plus MB equals AB and AN plus NC equals AC. Okay, segment addition. All right, now you know what? I really don't want to erase stuff. It's not a good idea. So let's go back on that. Okay, moving on. Now, let's go to my brainstorming. Remember, I can state all of this right here, okay, by substitution. All right, for NC, I can put AN because look, NC equals AN, and for MB right here, I can put AM because MB equals or is congruent to AM. Okay, so I am going to erase some of this here to give me some room, guys. Okay, so next, for those 1 or 2 students who are still awake in class, I can take this right here and we'll put it right here. Okay? We'll make that step 5. Okay? We're going to call it substitution. Substitution, okay? Okay, for this right here, for MB, right here, I put AM, which I'm allowed to do, okay? And for NC right here, I put AN, which I'm allowed to do, right here, okay? Okay, next. Now, I can put this right over here. Substitution. Okay, now watch where the substitution is. Okay, look right here. I have this, and I have this. Okay, now look what I did. I left this alone. This is right here. Okay, I left it alone. However, for this, I put this. How could I do that? Look in your given. Well, the given's gone, but if you look in your book, you will see in the given it said that AB is congruent to AC. So we can definitely do that. And now look, if AC is congruent to this, and AC is congruent to this, then I can definitely state that 2AN is congruent to 2AM. Substitution. Okay? Then divide both sides by 2, and we get AN is congruent to AM. Okay? And that would be division property. You divided both sides by 2. So division property. And now you're finally, step 9, you're ready to state that triangle ABN is congruent to triangle ACM. Now, how did I know that? Well, look, guys, in my proof, I stated this, okay, which is this. And in my proof, I stated this. You did, Mr. Earhart, where? It was in your given, right here. We didn't list it as in your given, okay? Up here in your given. And then we just stated this. Right here we stated this. AN is congruent to AM, which is this, congruent to this. So what do we have? Side, angle, side, congruent to side, angle, side. So my reason would be for stating that these two triangles are congruent would be side, angle, side. And now for step 10, I can state that, what was I trying to prove, guys? I was trying to prove that CN is congruent to BN. Hold on one second here. CM, right here, CM is congruent to BN. And we can state that. So I can say BN is congruent to CM, and the reason would be CPCTC. Wow, that was a tough proof, okay? But it was good. Very challenging, okay? I would love to hear from some of you. If some of you did this totally on your own, I would love to know that, okay? So if that happened, let me know, okay? All right, moving on. Number 16 through 19. Here we go. Match the special segment with the name of the point, okay? Very good. Well, look, guys. When you draw your altitudes, they all intersect at a point called the orthocenter, okay? So the orthocenter C would go with altitude, C, okay? Now, when you draw your perpendicular bisectors, the point where they intersect is called the circumcenter. So D, circumcenter, would go here with 17. Now, number 18, when you draw your medians, the point where all the medians intersect is called the centroid, which is right here, letter A. So 18 is letter A. And lastly, when you draw your angle bisectors, the point where they all intersect is called the incenter, which is letter B. So the answer would be letter B. And then lastly, finally, and my voice has about had it, so it's good. Number 20. The triangle formed by connecting the midpoints of the sides of an obtuse triangle is obtuse. Okay, well, let's say about that. Let's draw a really obvious obtuse triangle. Okay, really obviously obtuse. Comes down like this, over, then up. Okay, now connect the midpoints. Here's the midpoint. Here's the midpoint. Here's the midpoint. Now I'm glad they didn't ask us to prove this. I would not even want to try to prove it. But students, the answer is yes. And it's always going to be true. And here's why. because of this really wide angle here being larger than 180, then this point here is always going to be further to the left than this point here, in such a way that this angle here, right here, will always be obtuse. Okay, so we don't have to prove that. That's just a little thinking problem. I'm not going to get into that a whole lot, but the answer would be true. When you connect the midpoints of the sides of an obtuse triangle, the triangle that's formed on the inside will always be obtuse. Okay? And students, that's it. I hope this homework help video's been audible enough for you to hear. Sorry, my voice is really bad, and I hope that it's been a help to you. Okay? If you have any questions, don't hesitate to call or email.